how we get data with high quality? The first important thing is the hammer weight. We need to make sure we use heavy enough hammer to activate enough soil resistance. So according to the standards like ASTM and other specifications, 1% of the ultimate capacity is the lower limit, and 2% is more recommended. And for drilled shaft with large diameter, we may need bigger hammer weight, say more than 2%. And bigger hammer weight, lower drop height is preferred. That means we'd better to use bigger hammer weight, but with a lower hammer drop height, because this could produce lower stress to avoid breaking the pile head. For hydraulic hammer or diesel hammer, we may require less hammer weight because for hydraulic or diesel hammer, the drop height could be higher. And make sure we use hammer guide. Prepare the site for the guide installation. We need to make sure that the site is flat enough for the guide installation. And make sure the hammer center hits the pile center. Third, make sure the top surface of the pile and bottom surface of the hammer is flat, so we can avoid eccentricity problem. And the fourth, start with small drop height and increase the drop height gradually. Last one, protect concrete pile head in case of breaking the concrete. Usually we use a steel casing to protect the pile head. Here we have some pictures of the testing site. Test without guide may cause damage, and not only damage to the pile, but also could be damage to engineers. So it is not good. And if there's no protection, the pile head could be broken. It is not good. This is the eccentricity problem. We can see big difference between F1 and F2 if we check individual force. Even for F1, it is compression, and for F2, it is already tension. So it's very serious problem. Also this one, F1 and F2, big eccentricity problem. Also this one, very serious problem. And for this one, I think besides the eccentricity problem, we also have the problem of sensor installation, which we will discuss later. If we use a guide properly, the data quality will be better. So check this one, F1 and F2, a very small eccentricity problem, and the proportionality good. Data go to 0 at the end, very good. This one also. This is a diesel hammer. We know that usually diesel hammer or hydraulic hammer, they will produce a better data quality than free drop hammer. For this is diesel hammer, the proportionality very good, the eccentricity very small, and data go 0 at the end of data. So it's a perfect data. This is some hammer guide we're using. These hammer guides is usually used in China. And also we have some guides from other countries.